All right, so here we go. Picking up where we left off. We have an equation, and the equation is C equals 3.5G. That gives the cost in dollars. Capital C is the cost in dollars as a function of the number of gallons of gas, and the price per gallon is $3.50. And so the domain of the function C equals 3.5 times the number of gallons is restricted to non-negative numbers. Now, whenever that's a fancy way of saying positive and zero, right? So whenever you see the phrase non-negative, that means it's equal to or greater than zero. Okay? And if you think about that in the context of the problem, I could have 0 gallons of gas. I could have 0.5 gallons of gas. I could have 20 gallons of gas. But what I cannot have is -2 gallons of gas. Does that make sense? Well, no, you'd have 0. You'd run out of gas. He said you'd drive for a while. No. So, anyways, what's the question then? It says the domain of the function is restricted to non-negative. So the range of the function consists of non-negative numbers. This means that the domain of the inverse function is C is greater than 0. And so I'm going to pull this up here. This is the graph. I want you guys to sketch out the graph. This is really the graph of the equation. C is equal to, well, actually, this is the inverse function that they have here. And so there's some questions that we're going to answer, but let me have you write down this graph. Okay. So sketch out this graph as best you can. I would probably pick a point and label it so you could get an idea of the slope of this. And then we'll proceed. I'll write down the questions, but first write this down. Now, the question I have while you guys are writing this down is, how does Mr. Adams know that this is the inverse function? How does Mr. Adams know off the top of his head that this is the inverse function? Well, it's true. I am intelligent, and I have a master's degree, and I'm a math teacher. But what I'm trying to teach you is there's some clues here, okay? But I'm having I should probably turn the webcam off is what I should do. I didn't style my hair, because it looks so amazing all the other days. But anyways, let's I forget I'm recording sometimes. So my equation, and I'm going to write this slightly different. If I write my equation is C of x is equal to 3.5g, and it's actually not C of x. What would it be? C of what? C of g in function notation. So what is g? Isn't that the independent input, right? In other words, C of g is dependent upon the value of g. How many gallons? The cost is dependent upon the number of gallons I buy, right? So what's associated with the input? Well, that's the independent variable. It's arbitrary. That's a fancy math word that means that it could be anything that we want it to be based on the situation. That means that the output is dependent. In other words, the cost of gas depends on how many gallons I buy. This is almost always associated with the x value, and this is associated with the y values. So then that means C of X would be the cost. So if I were to look at the graph of this thing, I would have C of G as my y-axis, and then G would be my x-axis. And I'd have some graph that have a slope of 3.5 that would go through the origin looking like this. Okay? This would be C of G is equal to 3.5 times G. So the reason I knew is because this is how many gallons of gas would be my x-axis, and this would be cost, and that would be in dollars. Okay? But if I look at this graph here, I have the cost in dollars versus gallons of gas. That's how I knew it was the inverse. My x values and y values were flipped. So what are we doing in this section? We're finding the inverse function, right? Let's find the inverse function of this. So to find the inverse function of this, what's the first step that we do? Well, the first step is I'm going to replace the function notation with a y. So instead of saying C of G, I'm going to call this y. And then this would be 3.5x. Now, you don't have to write it that way. Technically, what I should do is I should write it like this. I should say C and G. Then what's the next step? I would solve for x, which is the independent variable. So in this case, what would I solve for? I'm going to solve for G. How do I solve for G? Divide by 3.5. Whatever I do on one side of the equal sign, I have to do to the other. 3.5 divided by 3.5 is 1. 1 times G is G. And then over here I've got C divided by 3.5. Now there's one last step for that, and I'm going to flip it back around. Take the G and replace it with inverse function notation. In other words, I would say C inverse of G is equal to C over, oh wait, yeah. Wow, I got to think this through. I'm going to plug in the cost. Well, don't worry about this notation. This is how they have it in your book. I kind of opened up a can of worms by starting to write it down that way. So this is the inverse function. Okay. And if you graph that, guess what it looks like? This. So this is G is equal to the cost per 3.5. So this function here, in other words, if I spend $20 in gas, let's write this out. So this would be 20, 6, where 20 is the cost in dollars, and this is the gallons of gas. If I spend about $20 in gas, I'm going to get about 6 gallons. Now that's not that's not 100% accurate. Actually, is it 20 or is it more like 20? Let's do the math here. It's actually $21. So it would be 21. I'm approximating it. It would be about 21 because smack dab in the middle is 21. So how could I verify that just to double check? Well, if I buy 6 gallons of gas and I multiply it by 350, I get $21, right? And if I plugged in 21 and divided it by 350, I would get 6. Does that make sense? So then the question goes on and it says a car's tank of gas holds 14 gallons and contains 4 gallons of gas when the driver stops to fill up the tank. The gas pump dispenses at a rate of 3 gallons per minute, and it gives us a funky equation. So I'm going to have to write some of this down. There's a part B to this. Okay, this is part B. Did you have everything written down from here, though, before I move forward? I'll give that a second before we move on to part B. So on these simple linear equations, we do this all the time. Gas is $4 a gallon. My car holds 15 gallons. How do I figure that out? 4 times 15 is 60. It cost me $60 to fill up the tank. I know this. If my son takes his car and he says, I spent $50, and I want to figure out how many gallons of gas he had to put in his car, I just take that 50 and divide it by 4. Does that make sense? So I'm using the original function, the cost per gallon, to calculate it one way, and then I do the inverse function to figure out if I know the cost of gas, how many gallons were purchased, right? We do this all the time. We just don't do it as formal by calculating the equation. We just kind of do the reverse math, right? The inverse operation, what I should say technically. Can I move on to the next slide? Okay. So for part B of this bad boy, it says that a car's gas tank holds 14 gallons of gas, contains 4 gallons of gas when the driver stops at a gas station to fill the tank. The pump dispenses gas at a rate of 5 gallons per minute. Given the equation, gallons equals 5 times T plus 4 gives the number of gallons of gasoline in the tank. And then it says the range of the function is between 4 and 14. So solve the given equation G for the inverse function. So again, what we're trying to figure out is how long will it take to fill up my car with gas. And if I have an equation, I can just plug in some numbers to this inverse function. So we're going to do this kind of the exact same way. So I start with the original equation. G is equal to T plus 4. All right. Now, again, this is the inverse function. Your textbook gives you the inverse function. So I think what they're trying to do is say, hey, when you're done with this, if you compare the graph of your inverse function to the graph that we give you, then you've done the math correctly. All right. Or the other option is that you could graph this function and the inverse function together, and they'll be symmetrical about the diagonal. So anyways, what's the first step? Solve for t, right? We're going to solve for the independent variable. We know that g depends on t because we're doing a bunch of math to t, right? But if you think about it, how many gallons do you have in the tank? Well, it depends on how many minutes you're pumping gas, right? So g is the dependent variable and t is the independent variable. So we're going to solve for t. How do I do that? What do I do first? Get t by itself. Solve for t. What do I do? Well, we could divide by 5 or we could subtract by 4. Which might be easier at the first step? Subtract 4. We could divide by 5 for sure, but then we got to divide all 3 terms by 5. But if I subtract by 4, I only have to divide once. So anyways, what I'm going to do here, 4 minus 4 is 0. That leaves me with 5t. And over here, I'm just going to say g minus 4. In the next step, we divide by 5. 5 divided by 5 is just t, so we get t is equal to g minus 4 all over, 5. So that's the equation. That's it. And then if you were to graph it based on the value for G, remember that they say that G lives between 4 and 14. So this is my domain, right, of the inverse, which is technically the range of the original function, right? I don't know if you guys are aware of that. I'm just throwing that in there. You probably should sketch it out, yeah. So if you're wondering, and I want you to think about this, so this point right here is 4 comma 0, and this point right here is 14 comma 2. And so my independent variable is gallons, right, comma the time in minutes. So what this is saying is that you can have 16 gallons, or I'm sorry, 14 gallons in 2 minutes. Well, why is that? Well, because the equation figures in the original 4 gallons that you have in your car. So if the car holds 14 gallons, but it has 4 gallons, how many gallons do you need to pump in? 10, right? Because 10 plus 4 is 14. And it pumps at a rate of 5 per minute, so 2 minutes will do it, right?